Good afternoon. Thank you for joining us today. My name is Sean. I am the wireless product manager here at Zyxel. Today's webinar is our Wi-Fi webinar. This is going to be an overview of all of the different access points that we offer. I'm going to start by talking about some of the different technologies and naming conventions we have, and then we'll go through the different access points. I'll start with our 11AC and Wi-Fi 6 products. And then at the end, we'll talk a little bit about our Wi-Fi 6E products. As we go through today, if you have any questions, use the question and answer box in the Zoom interface to send those questions in, and I'll do my best to answer them. So to start with, we've sort of split up our access points into three categories. We've got a series of access points sort of aimed at the prosumer space. Those ones we're only going to talk about briefly today. And then for those that are aimed at the more business-oriented space, we split those into two different categories. We have those that we call flexibility and those that we call ultimate. So when you're looking at the model numbers, basically anything that has that starts with the number 1 or 2 is part of our flexible series. And then the ultimate series, anything that starts with a 5 or 6 and has at least 3 numbers in the name is part of the ultimate series. And anything you see that only has 2 numbers in the model name, that is going to be something that comes from our prosumer line of products. So just to start with here, when it comes to the hardware design and philosophy, this is going to be true of all of our business class access points, as we put a lot of time and effort into the design of the hardware itself. Because of this, it allows our hardware to last longer and give you a little bit better performance. It's one of the reasons why we can offer lifetime warranties on sub $100 access points, where most of our competition in this space is offering 1 or 2 years. If you've ever seen us at a trade show, and we have some of our access points there, pick them up. You will see they weigh a lot more than what you're probably used to from other vendors, even very expensive other vendors. And that has to do with some of our design choices here. So one of the first ones is you will notice here on the back plate, there are a bunch of little dots. Those are openings and vent holes to let heat out. And then you will find pressed up against that here is a large metal heat shield. So the reason for this is we're dealing with solid state equipment here, and one of the leading causes of failure over time on solid state components is heat fatigue. The buildup of heat in there can over time cause the little switches that are part of the IC chips to fail. You can also put strain on solder joints. So by doing it and designing things this way, we draw the heat off the PCBA and off those components and help vent them out the back. You will also notice when you look at our PCBA board here that we have a lot more shielding on our board than most of our competition has on theirs. Generally, you will only see shielding around the Wi-Fi chips, where in our case, we've got shielding around a lot more. There's a couple different reasons for that. One of them just has to do with EMI, trying to reduce EMI interference between the different components on the board. We also add additional shielding that's designed to block out 4G and 5G signals. If you are deploying a network in an office building and they have a DAS solution that's designed to take outdoor 4G and 5G and distribute it indoors, those signals border some of the same channels that we use for Wi-Fi and can cause interference. So this helps reduce that. It also creates better isolation of the Wi-Fi chips from any stray signals that may reach them bypassing the antennas. Most of our APs will have then another large metal plate that sits above the PCBA. It helps a little bit with drawing heat off the board, but it's mainly there as a form of isolation, again, to isolate those components on the board from everything else. And then you will see we have our antennas mounted on their own board. Most of our competition mounts theirs directly onto the main PCBA. So again, by putting them up here and putting this noise shield behind them, it creates better isolation on those antennas. So it means that you get less noise. So when you've got a strong signal, it's not going to make much difference. But for those edge cases, those users that are just barely within range of the access point, it can make a huge difference as far as the quality of that connection. And then lastly, here on our products, we do not use any electrolytic capacitors. We only use solid state capacitors. So behind heat fatigue, failure of your capacitors is probably the next most common cause of failure on solid state components. The electrolytic capacitors are filled with sort of like a saltwater solution, and they can dry out, they can leak, they can expand due to steam being created inside them. So by eliminating electrolytic capacitors, it helps us increase the life of our products. The next thing we will talk about here is some of our antenna technology. So if you're looking at our product lineup on our website or on the price list from our salesperson, you may see some access points are listed as being dual optimized antennas. So that's something I don't believe any other vendor currently offers. So traditionally, an access point is designed, the antenna is built in. It's a single fixed antenna system that's designed with the idea that you're going to be mounting your access point on the ceiling above the area that's going to be covered. Unfortunately, out in the real world, you oftentimes have to mount those access points on a wall. For whatever reason, you cannot mount them on the ceiling. So again, they're by default, or your traditional access point, that antenna pattern is optimized for that ceiling mount, not for when it's on the wall. So when you mount them on the wall, you end up sending a lot of the signal up into the ceiling, a lot down into the floor. If you're in a multi-floor building, you may cause interference between the floors, and you just get a less than ideal coverage pattern. So with our dual optimized antenna devices, we have two sets of antennas built into the access point, one designed for your traditional ceiling mount and one that's designed and optimized for being mounted on a wall. So you can go in to our software and you can choose which antenna pattern you want to use based on where you've mounted that access point. So if you're mounting some access points on the wall, you switch them over into using the wall optimized antennas, and you will get a more ideal coverage pattern based on where you've installed those access points. The next technology, and we're going to spend a little bit of time delving into this here, is our smart antenna technology. If you're familiar with Ruckus offers their BeamFlex Plus. Their BeamFlex Plus is very similar to our smart antenna technology. Now, to sort of explain how this works, we're going to take sort of a step back here and just talk about Wi-Fi in general and some of the technology behind it. So when we're dealing with the 2.4 gigahertz spectrum here in North America, we've got 11 channels that you can choose from to use for your access points. The problem we run into here is that the channels that we actually use are at least 22 megahertz in size. And this entire area here is roughly 60 megahertz in size. So what happens is when you choose a channel, your signal is actually overlapping the nearby channels. So you can see here, we've chosen to broadcast on channel 6. It overlaps all the way from channel 4 to channel 8. So you end up in situations where you have overlap between different access points quite quickly and easily. If you have more than 3 APs, you're going to have overlap. And that causes interference issues. So with the 2.4 spectrum using a 20 megahertz channel, you've only got 3 channels that you can use before you have interference issues. Now, way back in 11N, they added the ability to speed things up by allowing you to use 40 megahertz channels. So again, there's only roughly about 60 megahertz of frequency that's available for you. So if you're using a 40 megahertz channel, it means you're going to overlap and have interference. As soon as you add a second device, it's also trying to use those 40 megahertz channels. This was one of the big reasons why there was a big push to move people from 2.4 to 5 gigahertz. 5 gigahertz opens up a lot more spectrum. So you can see here, if you're using these 20 megahertz channels, you've got something like 26 of them here that you can use that do not overlap or interfere with each other. So you can deploy a lot more access points out there then without having to worry about overlap issues and interference issues, assuming you're using 20 megahertz. Now you will notice here in the middle, there's a bunch of these channels though that are highlighted in the sort of orangey yellow color there that are called DFS channels. So let's talk about those real quick. So DFS channels are channels that were part of the 5 gigahertz spectrum. So originally, to use 5 gigahertz, you had to have a license, and these licenses were reserved for similar for certain different technologies. The most common of which is radar. Whether we're talking radar at an airport or weather radar, those are using those frequencies. So when the FCC decided to open up the 5 gigahertz spectrum to non-licensed devices such as Wi-Fi access points, they created a technology called DFS. And basically with DFS, Your access point is required before it starts broadcasting to make sure there are none of these legacy users using that spectrum. Um, so if it sees that there's a legacy device using it, it is not allowed to broadcast. In addition, if it starts broadcasting and then determines a legacy device is now using that frequency, it has to turn off and stop broadcasting. So in order to support this, devices that support these DFS channels have to be certified. This certification process can add up to 6 months to the FCC certification process. So because of that reason, what you find is a lot of consumer equipment, which is trying to get out to market as quick as possible, doesn't support DFS at launch and may or may not get a firmware upgrade that allows support of DFS. So that's one of the issues you run into if you're using these DFS channels. If you're having people bring their own devices, somebody may have a device that isn't capable of using these channels. And this is something that we get calls of tech support for all the time. You know, hey, we've got your access points deployed to this office, but your products aren't compatible with these 3 guys that we have. They can't get on your network. Why aren't you compatible with whatever brand of device they have? And usually what happens is we do some troubleshooting, we find out they're using DFS channels, and these users are positioned in a place where the nearby AP is using the DFS channels. The other issue you run into with these DFS channels is, again, if we detect, the AP detects that a legacy device is using that frequency, it has to turn off and change to a different channel, which can temporarily disconnect your users. So using these channels can also cause complaints in some areas where there may be a nearby legacy device, or there may be some sort of piece of industrial equipment that puts off interference that gets mistaken for a legacy device. So for those reasons, a lot of your deployments, especially like public area deployments, you can't use these DFS channels. So if you're not going to use DFS, you're down to just 9 non-overlapping 20 megahertz channels. And then, of course, if we want faster and faster speeds, part of the ways we get to faster speeds with Wi-Fi is increasing the channel bandwidth. So 11N allowed us to use 40 megahertz channels. So now you're talking about, if you're wanting to use 40 megahertz channels, essentially doubling your speed from 20 megahertz, you've now only got 4 non-overlapping channels that you can use. With 11AC, 80 megahertz channels became the default. So now you've only got 2 non-overlapping channels. So if you're trying to use 80 megahertz channels and you're trying to avoid DFS, as soon as you add a third access point, you're going to have interference because you're having to use the same channel on a different access point. And then with 11AC Wave 2 and now Wi-Fi 6, we have the ability to use 160 megahertz channels. Those have to use the DFS spectrum. So the reason I'm talking about all this has to do with what we call code channel interference. With Wi-Fi, each device has to essentially take turns broadcasting. If 2 or more devices broadcast at the same time, it causes interference, and generally the packets are dropped for both devices. You know, in the old days of networking with hubs and networking with hubs, you would call this collisions. You would end up with collisions. So this is what happens when you've got multiple access points operating at the same channel at the same time, is you start getting these collisions and it causes this code channel interference. Now, to be safe here, there is something called MU-MIMO, which allows multiple devices to broadcast at the same time, but I don't want to go into the technical details of that. But just in general, this is true. Each device has to take turns broadcasting. So as you add more and more devices onto the network, more and more likely it is that 2 or more devices will try to broadcast at the same time on the same channel. And this doesn't have to be other Wi-Fi devices. It can be any other device that's using wireless technology. It can also be caused by things like microwaves and stuff like that put out 2.4 or 5 gigahertz frequencies. So traditionally, the way you would deal with these code channel interference issues, at least between access points, is you would turn down the power of each access point to limit how far that signal goes. That does a great job of reducing the interference. The downside of it is you may end up lowering your signal to noise ratio and having performance issues by a different source. So smart antenna technology is designed to sort of solve all of this. It lets you put more users on the same access point before you start running into issues with them talking over each other. It allows you to put more access points into the same area without them causing interference to each other. And even in an open clean environment, it allows us to focus the beams at the users so you get better range. So this is just showing here as an example. Again, we've got our ceiling mount access point up here. Now we've got a source of interference. In this example, it's a microwave, which causes interference and causes users to drop. With smart antenna technology, instead of having this one fixed antenna pattern, we have literally hundreds of different antenna patterns to choose from. And our access point is able to go through those different antenna patterns and choose the antenna pattern that's best based on where the client device is in relationship to the access point. But our algorithm also looks at where other sources of use of that same channel are and chooses an antenna pattern that allows us to ignore those sources of interference, reducing the overall interference. And this works with any sort of client device. It doesn't require any special technology on the client, and it works with moving devices. So we're able to keep changing the antenna pattern as a mobile user walks around, something that some of the other technologies out there similar to this, like beamforming, are unable to do. So we've done some of our own testing here, so we compared our product here with a HP Aruba product. Both of them are a 4x4 Wi-Fi 6 access point. Our performance is in green, their performance is in blue. And as you can see on both transmit and receive, our access point with smart antenna significantly outperformed their access point without smart antenna technology. Now, a few years ago now, the University of Brescia in Italy, their networking group, saw claims that us and Ruckus make about the benefits of smart antenna, and they decided to go out and test it. So they bought one of our access points, they bought a Ruckus access point, they bought a Cisco and an HP Aruba. Cisco and HP do not offer smart antenna, and they put them through the test. So if you see there's a link at the bottom there, which takes you to their white paper where they summarize their report and all the testing they did and how they did it. A quick summary here is that in co-channel interference prone environments, smart antennas performed up to 70% better than non-smart antenna access points. Specifically us versus Cisco, up to a 56% performance improvement. And we did better than Ruckus did, up to 45% better, depending on the test. If you go to Google and type in like Zyxel smart antenna white paper, we do have a white paper that summarizes everything in the report, distills it down to, I think, a single 2-page document. Or you can always dig up the original report and go through it yourself if you're interested. So now let's talk a little bit about the technology behind Wi-Fi 6, because this is still considered a rather new technology out there. I know there's still partners that haven't made the jump to it or have just recently made the jump. So Wi-Fi 6 is a new standard that came out a couple years ago. This is the first upgrade to both 5 gigahertz and 2.4 gigahertz networking since 11N. 11AC and 11AC Wave 2 only upgraded the 5 gigahertz network. With Wi-Fi 6, you've upgraded the 2.4 and the 6 gigahertz network. So a huge jump up as far as 2.4 performance goes. One thing though to keep in mind is that some of the cheaper Wi-Fi 6 products out there, Ubiquiti's U6 Lite, for instance, only puts Wi-Fi 6 in the 5 gigahertz radio. So if you buy one of those access points, you're still getting 11N technology on the 2.4 radio. So something to keep in mind when you're shopping around out there looking at Wi-Fi 6 products. So in theory, Wi-Fi 6 can provide a top speed of nearly 10 gigabits over Wi-Fi. And just like other Wi-Fi technologies, that's looking at the data rate, the total amount of data transmitted between wireless devices, which includes a lot of overhead. So if you do a speed test, roughly you're looking at about half that speed is what could be achievable as far as an application is concerned. So anyways, up to 10 gigahertz, although there's not a lot of products that support that full speed out there. A lot of technology improvements that are allowed to increase capacity. So similar to our smart antenna technology, Wi-Fi 6 allows you to have more APs in the same area and more users per AP. And the technology is doing this and achieving this differently than smart antenna. So you can combine those two together and get a bigger boost in performance because they complement each other. So some of the technologies on there, Wi-Fi with Wi-Fi 6 has been upgraded from OFDM to OFDMA. which allows much better segregation of the available wireless spectrum and divvying it up between user devices. Something called spatial use, which uses BSS coloring to basically let devices know when you're transmitting packets, who these packets are intended for, so devices can ignore things that aren't intended for them. So this is just showing here the improvements as far as capacity on an access point. So this orange line here, or the bottom line, this is showing you 11AC performance. The lighter orange line up here is Wi-Fi 6 performance. And basically what we're looking at here is the aggregated throughput of all clients as you add additional clients onto the access point. So what you see here is with the older 11AC technology, as you add users onto the same access point, the maximum aggregated throughput drops. And this has to do with just the inefficiency with which wireless users are able to use the available airtime without stepping on each other's toes. As you add more users, you get more interference issues and overall performance degrades. So you see here with Wi-Fi 6, it stays relatively flat no matter how many users you have on that access point. Same performance here when you've got multiple APs operating at the same time. So now we'll talk about wireless controllers and management. So for those of you that don't know, our security appliances, the Zywall series, the USG Flex, the ATPs, they have a built-in wireless LAN controller that you can use to manage many of our different access point models. It's very similar to Nebula in the feature set that it offers. So it does things like, intelligent dynamic channel selection, zero AP configuration. So you don't have to configure the APs to tell them you're using a controller. They will find the controller on their own. Mesh technologies, fast roaming. One of the only technologies here that is not available in Nebula is rogue AP detection and isolation. We offer dynamic VLANs, AP load balancing, client isolation, et cetera, captive portal. So I just wanted to talk a little bit about that. Now we do also have Nebula, which is our cloud managed solution, which most of you are probably already familiar with. If not, join one of our webinars. We do a webinar every month where we talk about Nebula. But that's the main way these days we suggest managing most of our access points in a multi-AP deployment is our free cloud management solution, Nebula. So I want to start talking now about some of the different access points. So one area where we have a lot of confusion is our AX1800 access points, because we've got a lot of AX1800 access points in our lineup. So I want to spend a few slides here just talking about nothing but these Wi-Fi 6 AX1800 access points. So we're going to start with our prosumer products. This is the only time today I'm going to really talk about these. So we've got two models, an NWA 50AX and an NWA 55AXE. One is indoors, the AXE is an outdoor product. Otherwise, they're basically the same. The NWA 50AX is an Amazon exclusive. We do not sell them through distribution. The NWA 55AXE is available through distribution if you are interested in them. So one of the first things to talk about here is these two models are what I'm going to call a Wi-Fi 6 Lite product. So these are the only access points that almost the only access points we have that don't have the full Wi-Fi 6 feature set built into them. So for instance, when it comes to multi-user MIMO, Wi-Fi 6 allows upstream MU-MIMO. These only support downstream MU-MIMO. These only support OFDMA in the downstream direction. They do not support upstream OFDMA, and they do not support enterprise security. So you can't use 802.1x authentication with your wireless users. In addition to being what I'm going to call, a Wi-Fi 6 Lite product, these products also are missing some of the other features that you would expect in an access point, in a business class access point. So some of the features that you are missing with these that may be important to you and your customers, captive portal technology. There is no captive portal in these models. There is no layer 2 isolation. There is no load balancing. There is no dynamic pre-shared key. There is no being able to do AP-based NATing on different SSIDs, no SNMP. et cetera, et cetera. Now the 55, the outdoor one, does support Nebula Bridge. So if you're looking for a easy way to make outdoor point-to-point links, the NWA 55 AXE is really good for that. But because of some of these missing features here, this is why we call it prosumer. A lot of these features are something that you are going to need in a business deployment. And these have a 2-year warranty on them. The step up from this, which is available through distribution, is the NWA 90AX. It is very similar here, and that is a Wi-Fi 6 Lite product. So it's missing like the multi-user MIMO upstream and the OFDMA upstream. It does add support for the full WPA3, including enterprise. Supports MAC authentication. It supports radius authentication. It supports captive portal. And it supports layer 2 isolation. So it's those core features that you may want. So if you're looking for a really inexpensive access point, it's a little bit more capable than over here, the NWA 90AX is what you're looking for. Now, when we get up to our true business class products, we're looking at the NWA 110AX. So again, all of these are the same Wi-Fi 6 AX1800 technology. Now, when you jump up to the NWA 110AX, you get full Wi-Fi 6 support. So all of the core Wi-Fi 6 features are supported, unlike these guys here. And we unlock basically all of the features you would expect to find on our business class access point. So it adds things like load balancing, dynamic pre-shared key, SSID NAT, SNMP, et cetera, et cetera. This model also adds our optional CNP license. So if you want to add that CNP security, it is available there. And then also the difference between these models and this model is this one gives you a lifetime warranty, where these guys here are just a 2-year warranty. So that's why there's a cost increase, even though the advertised speed of AX1800 seems to be the same on the surface. And then the next model above that is the WAX510D. So what this one does is this one's going to upgrade our antenna from a standard antenna to that dual optimized antenna I was talking about earlier. And it is a Nebula Flex Pro product. So this one can be managed by a Zyxel as a wireless LAN controller. And it comes bundled with 1 year of the Nebula Flex Pro license, which unlocks additional SMB oriented features in the Nebula interface. Okay, so that's it for AX1800. Now we'll start just going through all of our access points. So we'll start here with our 11AEC products. These are going to be that flexible series. So these can be managed directly through the GUI, or you can manage them with our free Nebula cloud. So we've got 2 models here. We've got an NWA 1123 ACV3 and the NWA 1123 AC Pro. Standard antenna, dual optimized antenna. And this one gives you 3x3 on the spatial streams, where this guy here is only 2x2. And the Pro also gets you a pass-through Ethernet port, where the 1123 ACV3 does not have it. The next step up from there is our Wi-Fi 6 access points. So we have the NWA 110AX, which we just talked about. And then we have the NWA 210AX. And the main difference between these two is going to be the 210 has twice the speed on the 5 gigahertz radio. So it's got 4 spatial streams versus 2 spatial streams on the 110. And this one also does have a multi-gig LAN port. So it's a 2.5 gig LAN port and a 1 gig pass-through port. So going up to our Ultimate series. So Ultimate series, again, are those that can be managed directly, those that can be managed with the free Nebula cloud, or they can be managed with a local controller. And they come bundled with a 1 year of the Nebula Flex Pro licensing if you want to use it. So we've got the WAC500. This is going to be our cheapest access point. It's part of the Ultimate series. And this access point also works for the security feature we offered called Secure Wi-Fi, which allows you to convert an access point into a centrally managed VPN appliance. So if you have users at home that want to get onto the network, you can convert the WAC500 essentially into a configuration-free VPN appliance that you give to the end user. They take home, plug into their existing router, and it allows them then to easily connect to that and VPN back into the office. We still have our WAC 6103D-I, formerly one of our best-selling access points out there. So this is a 3x3 It's got 2 Ethernet ports on it, and it's got the dual optimized antennas. For those of you doing hospitality, we have our 2 hospitality-oriented access points. So what makes these hospitality-oriented? One is the form factor. They're relatively small, and they're designed to be mounted directly onto a wall plate and to allow the Ethernet cable to come out from the wall directly into the back of the AP itself. The other technology that these guys have is they have several pass-through ports, including one port that passes through PoE. So if you're doing hotel deployments, you install this in the room. You've got Ethernet out that you can run to, say, a set-top box to provide IPTV. You've got another port with PoE pass-through that can power up IP phone or an ATA or something like that. The primary difference between these 2 models is the 5302 has more Ethernet ports than the WAC 500H, and the WAC 5302 has smart antenna built in, where the WAC 500H does not have smart antenna. Moving on from there, our Wi-Fi 6 lineup starts with the WAC 510D, which we talked about earlier, that AX1800 model. The next step up from that is the WAX610D. So that one doubles your Wi-Fi speed on the 5 gigahertz radio, and it adds that pass-through port. Step up from there is the WAX630S. So this one gives you smart antenna technology. Basically, it takes that WAX610D, adds smart antenna to it. And then our flagship product here, the WAX650S. So this is our fastest access point, 4 spatial streams on both the 2.4 and the 5 gigahertz radio. It has a 3rd dedicated monitoring radio that you can use. This is our access point that has a 5 gig uplink port. So you're making sure that your Ethernet is not throttling your Wi-Fi performance. And this one also has Bluetooth BLE built in. So that's it as far as the indoor access points go. We also have a couple models of outdoor access points still. These are 11 AC based. We have the WAC 6553D-E, 3x3 radio, hardened IP66 enclosure, and this one has a heater built in for extremely cold environments. We have the WAC 6552D-S, a little bit slower. It's a 2x2, so 2 spatial streams on both radios, but it has smart antenna technology built in. It's specifically designed to be used for situations, not only doing point-to-point links, but also for doing really dense environments like stadiums and things like that. And then we do also offer here an outdoor enclosure that you can put many of our indoor access points into. So it's designed to help waterproof those access points. So you take an indoor access point mounted inside, helps protect it from the water. It also increases the operating range that those access points can be used in. So you can always check our website to see which access points are compatible with it, but most of our most popular models will fit in there. So now we'll talk about Wi-Fi 6E. So Wi-Fi 6E is something relatively new. And some of the details are still being hashed out in court. So what's happened here is, like we did with 5 gigahertz, the FCC said, hey, you know, this 6 gigahertz spectrum that requires licenses, we want to open it up for unlicensed use and allow Wi-Fi devices to operate on this area here, this new channel. So the benefits of using 6 gigahertz here is significantly more bandwidth is available than 2.4 and 5 gigahertz combined. So more bandwidth means faster speeds and less interference, because you've got more flexibility of which channels you want to use. As you see here in this middle slide, there are 760 megahertz channels that are available to be used versus 0 in 2.4 and just 2 in the 5 gigahertz. And basically, there's very little using the 6 gigahertz spectrum outside of Wi-Fi devices, so you don't have to worry about interference from other wireless devices in your area. Now, the downside, like I mentioned, is that this 6 gigahertz spectrum was previously and continues to still be used by other legacy licensed users. So because of that, the FCC has proposed a technology similar to DFS, but a little bit nicer to use, um, to prevent there to being conflicting issues. Unfortunately, the FCC has yet to finalize the rules on using that, and there are several lawsuits trying to block the FCC from completing that. So for that reason, Wi-Fi 6E is only available to be used indoors in North America. You are not allowed to use Wi-Fi 6E outdoors at this time. So we will have outdoor Wi-Fi 6E products in the future, but it's going to wait for the FCC to finally publish the final rules on how to implement it, and possibly for some of these lawsuits to finish up. So we'll see how that goes. But just to show here, you can see here Wi-Fi 6, bigger than 2.4 and 5 gigahertz combined as far as the amount of bandwidth that's available. Now, the downsides for using Wi-Fi 6E, one is as frequency goes up, range goes down. So that's why 2.4 always has better range than 5 gigahertz. So 6 gigahertz is going to have even less range than 5. And we've seen that in reviews of people complaining how bad the coverage is. And that's why. It's because 6 gigahertz just physically is not capable of transmitting as far as 5 gigahertz and 2.4 are. And of course, the other trade-off here when it comes to 6 gigahertz use is just that this is new technology and there's not a lot of devices currently that support 6 gigahertz. It's a completely different frequency, so it does require different hardware that's specifically built to support 6 gigahertz with 6 gigahertz chips, amplifiers, and antennas. So right now, you pretty much only see 6E support in flagship phones, like my Google 6 Pro supports it. I think most of the newer iPhones support it, and some of the higher end laptops. But it's going to be a while before this starts showing up in your, typical Amazon $99, tablet or something like that. But the main benefit for 6 gigahertz here is for dense deployments, allowing you to cram a bunch of access points at full speed into the same area and not worry about the channels overlapping with them, being able to distribute a lot of users across all those different channels so they're not interfering with each other, or for, theoretical, really high bandwidth demanding applications. Although there's really not a lot that's out there today, it's something to future-proof your network. So now on to our access points that support Wi-Fi 6E. We've got 3 models. The first 2 I'm going to talk about, we are calling band flex. So what this means is these access points have a 2.4 radio in them, and then they have a second radio that can operate at either 5 gigahertz or 6 gigahertz, but not both at the same time. And the main reason for doing that is, like I mentioned before, at least at this moment, there's not a lot of devices that use 6 gigahertz. So it allows you to, support your existing 5 gigahertz users today. And then at some point in the future, once 6 gigahertz becomes more widespread, then you can move those users over to 6 gigahertz when that's available for you. Or it allows you to add 6 gigahertz to your existing network really easily, just by replacing just a few of your access points or adding a couple additional access points broadcasting on 6 gigahertz for your 6 gigahertz users. So for instance, you may not need 6 gigahertz in the warehouse where all of your equipment may still be using 2.4, but you may want 6 gigahertz on the sales floor or something like that, where people are more likely to be using, higher end laptops and things like that. So the beginning one here, our entry-level model, it's a sub $200 access point, is the NWA 220 AX-6E. So this provides one radio at 2x2, one radio at 4x4. It's a Nebula Flex device. The step up from that is the WAX620D-6E, basically same as the 220, but it adds dual optimized antennas and adds the Nebula Flex Pro features. So you get that 1-year Pro license, and you get the ability to manage this with one of our Zywalls as a local controller. And then for those of you looking for a true tri-band solution, something that supports 2.4, 5 gigahertz, and 6 gigahertz all at the same time, we have our WAX640S-6E. This is available now. So one radio is 4x4, the other 2 are 2x2 radios, but all 3 of them are broadcasting at the same time. And again, this is a Nebula Flex Pro product. It has a 2.5 gig multi-gig Ethernet uplink port, and it has smart antenna technology. So this is right up there with that 650S as far as flagship goes. Aggregated speed's about the same, but you're missing out on the Bluetooth radio. And that, guys, is it as far as our products go. I've just got a couple slides here comparing us to some of our competition. So one of the models we talked about earlier was the NWA 1123 AC Pro. So this access point is designed to compete primarily with the Ubiquiti UAP AC Pro. Should be roughly the same price or less. And it gets you a lifetime warranty versus a 1-year warranty. It gets you much higher output power on the radio than you get with the Ubiquiti product. Gives you dual optimized antenna versus the standard single standard antenna on the Ubiquiti. Support for SNMP V2C and V3, where Ubiquiti only supports SNMP V1. Support for IPv6, etc. Next, we'll jump up to our Wi-Fi 6 AX1800 product here, the WAX510D. So this is competing with something like the Aruba AP505 or on the lower end Ingenius's products here. So there's two different versions of the Ingenius product. They're both the same hardware. One is cloud, one is not. Obviously with Zyxel, doesn't matter. Our 510D is cloud, is not. If you want it to be cloud, it's local managed. If you want it to local managed, it's a local controller managed if you want that. So we have the flexibility there. Now, one of the key things here is we have support for full Wi-Fi 6. With the Ingenius products here, these are using chipsets from the early days of Wi-Fi 6 that are missing most of those important features that are part of Wi-Fi 6. So it's very similar to like our NWA 50AX as far as them missing out on upstream OFDMA, upstream MIMO. They're missing out on BSS coloring. We offer that dual optimized antenna versus static here on the Aruba and the Ingenius product. Higher output power than the Aruba and Ingenius product. So we'll go on from there to the 650S. So this competes with like a Cisco Meraki MR45 or a Ruckus R750. So you can see we've got better output power than most of our competition here. All of us are offering 4x4 on both radios. We have that built-in monitoring radio, which is missing from the Aruba and Ruckus products. We have a 5 gig uplink port, which is missing from the Cisco and Aruba products. We have that pass-through LAN port, which is missing on the Cisco products. And of course, we have the free cloud, which none of our competitors offer. And with that, guys, that is the end of today's presentation. No questions have come in, but if you do have some, send them in with the question and answer box there. I will try to answer them for you while we wait. Just wanted to point you out to our YouTube channel. For North America, it's called Zyxel America channel. There's lots of different Zyxel channels on YouTube, so search for Zyxel America channel, and that's where we post most of our webinars. So if you missed a webinar, you had to leave early, or you saw one, and you think one of your coworkers should watch it, they normally get posted within about 24 to 48 hours onto that YouTube channel, so you can watch it later. And then, feel free to reach out to us on LinkedIn and connect to us there. And then also, I do want to draw your attention here to our user forums. It's a really good resource that a lot of people have been overlooking. You just go to forum.zyxel.com. This is for Zyxel installers and users to be able to talk to each other, help each other out. But this is also where we generally announce things first. This is where you will find release notes, security bulletins, things like that. And you will find our R&D and product management teams occasionally wading into the conversations to answer questions. Even if they are not responding to you, they are monitoring those. So we keep an eye on that to try to figure out, what features people are asking for, which improvements people are looking for, and to figure out what sort of priority to put the different requests that we're always getting. So check them out, participate there, but good source of information there and a way to keep on top of things. We've got some questions, so I'm going to go through some of these here real quick. Richard is asking what the monitoring radio is used for. So the 650S has that dedicated monitoring radio. It can be used if you are using the Zywalls as a wireless controller. You can use that third radio for providing rogue AP detection. It can also be used for using WDS. So one of the challenges that you run into with WDS is you're broadcasting on one channel and you hear noise, you have to stop broadcasting and change channel. So if you choose to change channel to a different WDS channel, you've got to pause and wait to make sure that channel is not being used. With a third dedicated monitoring radio, it can always be set to monitoring different WDS channels. So if your broadcast radio has to switch channels, it can know which other WDS channel it can use without needing to wait to see if somebody else is using it. Anthony is asking for an NFR program for wireless APs. We do have one for our partners. So if you want an NFR, you need to be a Zyxel partner. So you sign up for that on our website. Once you get approved there, you can request it from your salesperson. So it would be Andy, Jacob, or David. They can help hook you up with ordering an NFR if you need one. Anonymous is asking what our primary distribution channels for wireless AP devices are. So our official distribution channels, and these are where resellers would buy the product from, are going to be D&H, Ingram Micro, Cynix, which is now just in the process of merging with Tech Data, Target. So Target distribution out of the East Coast, not to be confused with Target the stores. So when you search for it, search Target distribution. Or you can go to our website. We have them all listed there with links to them. And then Wave is another one. So those are our primary distributors where you're going to be able to buy and order our products. If you are an end user, you would buy from one of our resellers or online or whatever. Ken says he would prefer to see a WAX 630S instead of the 650S. I'll keep that in mind for future webinars to see if we can add a slide in there for the 630S. Richard is asking if we automatically get a link to the video. I don't think they send one out. I don't think they do. So it just gets posted to that YouTube channel. So you just go to YouTube and like I said, Zyxel America channel. All of our webinars are going to get put there automatically. And you will find many different versions of them because several of these webinars, like my Nebula webinar, I do it every month. So every time I've done it, it gets recorded and it gets put up there. So you can go back in time and see older ones or newer ones, but they'll all show up there. Like I said, it's generally 24 hours, at most 48 hours from when we do the webinars before they'll show up there. But yeah, I don't think marketing sends out links to them. You can always email your salesperson. Again, Andy, Jacob, David, and say that you want it and they can always provide it to you. And that looks like that's it as far as the questions go. So I'm going to go ahead and end today's webinar. Thank you for joining us and be sure to check out some of the other webinars that we're putting out there. Thank you. Oh, we got one more question. I'll go ahead and answer this here. So Richard is asking, with smart antennas, is it better to add more WAPs to an area to increase capacity? I'm just going to say that's something you should discuss with your salesperson for the application. I'm going to consider it just sort of too vague, and there's some different things that'll go into it. But in general, the denser the environment, the more users you have. If anytime you're dealing with a lot of users in the same area, it's generally a good idea to switch to smart antenna and probably add more. I think we generally say it depends on the application and what they're doing. Like for classrooms, we generally say if you've got like 30 students, you should have 2 APs in there. But for bigger, deployments like hotels and things like that, open areas, meeting rooms, we generally say, 1 AP per 50 users. But yeah, if you're having to add more users or more access points to distribute those users, always a good idea to use smart antenna to reduce the risk of interference. And with that, I'm going to go ahead and end today's webinar. Any other questions, just send them into your salesperson and they'll forward them to me. Thanks, guys.